Hello everyone, my name is Shiva and my teammate is Dilip Raja, and our project title is Detection of Cyberbullying on Social Media Using Machine Learning. We propose a strategy for categorizing text into hate speech and non-hate speech in the study. This study focuses on finding objectionable information and bullying statements in social network shared data. We'll use 31,935 tweets from the hate speech and offensive language dataset for this study. The dataset had a significant skew or imbalance with 93% of tweets containing no hate speech labels and 7% containing hate speech labels. Intelligent and sophisticated methods are needed for automated decision of these situations. For detecting cyberbullying, existing classical machine learning methods like random forest, SVM, naive Bayes with text cleaning have many bottlenecks and only about 90% accuracy. We show how state-of-art deep learning NLP language models can overcome these bottlenecks with better accuracy and semantic understanding with hate and no hate tweets. Bullying or harassment that takes place online is known as cyberbullying. As the digital environment has grown and technology has improved, it has become more and more prevalent, especially among youth, in many circumstances. Cyberbullying is a continuation of existing traditional bullying. Most often, students who are bullied online have also been bullied in more conventional ways in past. Few children experience bullying completely online because these cyber victims are frequently physically larger pupils. Bullies favor online confrontations over in-person interactions at school. According to other studies, cyberbullying increased during the COVID-19 pandemic when many children and adults were isolated at home and consequently spent more time online than had before the pandemic. Cyberstalking is a type of internet harassment where a victim is stalked using electronic communications because there is typically a real danger to victim safety. This type of cyberbullying is regarded as being more hazardous than others. Cyberstalkers may send repeated communications with the intention of threatening or harassing people, and they may also overtly encourage others to do the same by acting their victim and asking for contact information. The introduction of several social network sites in present trend has substantially increased the accessibility of communications, multimedia, and e-commerce service. For instance, the social media platform Twitter, which has over 700 million members, offers extensive microblogging service on a huge scale on Twitter. 400 million microblogs are created each day. More than 30% of accounts on social media platforms like Twitter, Facebook, Sina, and others are fraudulent, duplicate, or phony. However, contemporary social media platforms do not place a great focus on services like anonymous user tracking. Social network services today must concentrate on user microblogs and track user behavior regardless of whether a user is anonymous or not. Few services providing concepts to tracking the attackers like using profile matching techniques and network based techniques, etc., but in real time to apply those concepts in social media network is less practical. Google AI language group researchers have published bidirectional encoder representations form transformers. The proposal of a transformer-based bidirectional language model is recognized as turning point in the field of NLP by introducing two novel pre-training tasks, the mask language model and next sentence prediction task. BERT addresses the unidirectional limitations by using the transformer encoder as the structure of pre-trained model. BERT improves the current performance for 11 NLP tasks and its enhanced variations. Albert and Robert also reached great success. In order to improve accuracy using these language models, will further investigate and optimize cutting edge models like Albert, Robot, etc. Without having to alter the underlying hardware infrastructure, artificial intelligence has advanced significantly. An ancient computer system can be used to run an artificial intelligence application. On the other hand, machine learning has endless positive effects. One area of artificial intelligence that enables machines to read, comprehend, and convey meaning is natural language processing. In the fields of healthcare, journalism, finance, and human resource, NLP has had a great success. A typical NLP problem is text classification, which involves labeling or categorizing text. Text classification has a variety of useful applications that are frequently utilized in production by some of the biggest businesses around today. Sentiment analysis, one of the most liked methods of text classification, labels as being good, negative, or neutral to a sequence of text. Robota stands for Robustly Optimized BERT Pre-Training Approach. It was presented by researchers at Facebook and Washington University. The goal of this paper was to optimize the training of BERT architecture to take lesser time during pre-training. BERT is basically an encoder stack of transformer architecture. A transformer architecture is an encoder-decoder network that uses self-attention on the encoder side and attention on the decoder side. BERT base has 12 layers in the encoder stack, while BERT large has 24 layers in the encoder stack. In addition, large and baseboard architectures have more attention heads and larger feed-forward networks than the transformer architecture proposed in the original paper. It has 8 attention heads and 512 hidden units, while BERT large has 340M parameters. BERT base only has 110M. On the numerous tasks involving natural language processing and language modeling, BERT was able to increase accuracy. The key innovation offered by this work is the ability to apply semi-supervised learning for the variety of NLP tasks, enabling transfer learning in NLP. As of December 2019, it was used in 70 languages in Google search as well.
So here we can see in this figure we have trained the dataset from an open source where we have two classes which are non-offensive and offensive. To get the accurate prediction, we need to discard the items which are less than 5 words in the statement. The above illustration depicts the frequency of documents of a given length with respect to density. In this figure, we have used Robota classifier to train the model and used 12 number of epochs. Optimizer we used here is AdamW. In the initial stage, one of 12 epochs, we got the train loss to be 0.54 and valid loss to be 0.03. For 6 of 12 epochs, we got the train loss to be 0.10 and valid loss to be 0.11. Likewise, when we used 12 of 12 epochs, we got the train loss to be 0.07 and valid loss to be 0.11. As we can see that the train loss and valid loss is gradually got decreased. So here's a confusion matrix when we train our model. We have taken 2065 non-offensive statements, out of which 65 statements gave us wrong predictions, and for 2000 statements got right predictions. Similarly, we have trained 414 offensive statements in which 343 statements were predicted correctly and the rest 71 were wrong predictions. We got precision around 0.96% and recall with 0.96, also with F1 score around 0.96%. Also from offensive statements, we got precision around 0.84, recall with 0.83 and F1 score was 0.83%. Therefore, from Robota model, the average accuracy was around 0.94%. So here the previously used algorithms and datasets for detection of cyberbullying project. Using Naive-Bayes support vector machine J48 XGBoost sequential minimal optimization algorithms, they have got around 60 to 80% using different datasets like Wikipedia, YouTube, Reddit, FormSpring. So by using natural language processing model, that is Robota model, using Twitter dataset, we have achieved to get around 94%. So we can see that in these two pictures, when we type any word, it detects whether it comes under offensive or non-offensive statements. We took 40 tokens as the length of statement. When we enter any statement, the starting token will be 0 and all the words in the statement will be converted into numbers, and the statement will be ended by token 2 by default. So here is the end of our presentation. Thank you.
Thank you.